And today you are going to talk about the big data, deep learning, and also the cognitive computing. Okay. For the people who don't know you, you coordinate the big data at Chalmers and also engage in urban futures and the green growth. Are you going to talk anything about that today?
I will mention something about that.
Okay,
yes.
Excellent. So,
yeah, so I should have said that Patrick maybe already did my talk already, because he more or less mentioned all the topics that I was going to talk about. So I'm the king of the buzzwords today. So it's big data, deep learning, and cognitive computing. But Patrick already talked about that, and he basically made many of the points that I was going to make. So it's a good start. I can just amplify and give another perspective. I have to figure out how this works. Yeah. Okay, so I'll start from an economics perspective. So this is an interesting book that came out very recently, just earlier this year, called The Second Machine Age. And what it starts off is talking about the kind of brilliant technologies that we've been hearing about today, and especially in the last talk. The robotics revolution is one of them. Google cars is another example. So this is a book written by two economists from MIT. And they talk about this as ushering in the second machine age. So the first machine age is, we know it as the Industrial Revolution, when steam power took over human labor. So brawn was replaced by steam power in the first machine age. And so these two economists, they make the argument that we are now witnessing the second machine age, and this will be the replacement of brain, the cognitive power of humans by machines. And that's the era of artificial intelligence and machine learning. And we've heard about all the, we've seen some wonderful technologies, amazing technologies that are coming up in this. But if you look at the economists, and you take the economist point of view, this bright picture also comes with a problem. And that has to do with what is, the problem of jobs. So this is two well-known reports that came out recently. So there was a report from the Oxford Martin School, which estimated that nearly half of all jobs in the US would completely disappear because of automation. And a similar study was made very recently in Sweden, commissioned by the SSF and carried out by a well-known economist in Sweden called Stefan Folster. And they reached a very similar conclusion about Sweden, that nearly half of the jobs in Sweden are going to disappear because of automation. So you have the brilliant technologies on the one hand, but you have to contend with this problem. This is a major problem in society. How are you going to deal with a stable society, stable, sustainable society, when the age of automation is upon us? So this is, the solution is exactly what we have heard about before. The solution is going to be to think about the age of cognitive computing. And that is, instead of thinking about machines replacing or displacing humans, think about not automating, but augmenting human capabilities. So what new feats would we be capable of if we could achieve this kind of collaboration between humans and computers? And cognitive computing is exactly about harnessing these new technologies to create cognitive assistance that will augment human capabilities to enable new things that would not have been possible otherwise. And a very good example, one of the best-known examples of that, is the picture on the right, which is the IBM system called Watson. So many of you may have heard about the amazing victory that Watson scored in the Jeopardy competition on TV. This is a competition where humans, are supposed to be very good at answering questions, and it requires a lot of understanding and to be able to answer those questions. But the IBM Watson system completely devastated all the best human opponents. So it beat the human opponents by a very wide margin. So IBM Watson is an example of the kind of cognitive systems that are that will address these questions of using the power of these new technologies for societal benefit. So the Watson system, for example, it won the Jeopardy competition, which was a great demonstration of its power, But now it's really going to do the real thing, the real useful task for society. For example, to use doctors in creating a diagnosis for cancer. So Watson is now being used in cancer systems, cancer hospitals in the US in order to assist a doctor to make a better diagnosis, better treatment, etc. And we will probably see this technology more and more in our lives. Here's another example, which is in real life. This is a system called Waze. It's used in California for people driving. It uses the connected capabilities of cars and people and automated systems in order to simplify traffic problems. So let me show you a short film now, just to show you how these things in a mock-up system. Can we go
Today, more people live in cities than ever before,
1.5 minutes.
And for good reason. They're
Oops.
in action, the Management Center. SuperCity has just implemented our Emergency Management Center, or EMC, to help its emergency manager, Kathy, better plan for and respond to disasters and emergencies. SuperCity has a population of 5 million and is located along the coast. Weather feeds into the EMC have alerted Kathy that a Category 3 or 4 hurricane is approaching, and that SuperCity could be in its path. City leaders set up an operations center, a location where Kathy and officials from relevant city agencies can convene to share information, coordinate efforts, and readily tap into the insight provided by the EMC.
So this is an example of
a few days out
stakeholders
landfall,
collaborating
Kathy
with
uses the EMC to
automated
closely
agents.
storm data and collect information from responders and key stakeholders on resources that are available to help respond to and mitigate impact. Even though these data come from varied sources and agencies, Kathy is able to integrate the data due to application program interfaces, or APIs, that are created to enable the data sets to talk to each other inside EMC's software. This integration includes both structured data, which resides in a fixed field within a record or file, and unstructured data, such as photos, videos, closed-circuit television surveillance, web pages, streaming instrument data, emails, social media, etc. The EMC integrates data that is historical and current, combining input from things and people. As the city's relevant data is gathered on its critical infrastructure and key resources, the EMC cross-references this with the storm's predicted path to see where the city will be affected, where emergency resources may be allocated, and what level of resources may be needed for response. This type of analysis is enabled by the EMC's sophisticated analytics engines that automatically process the data, revealing insight into relevant performance indicators and trends around emergency response, providing Kathy and her Ops Center team with data quality, not just data quantity. Using EMC's predictive modeling capabilities, they also gain insight on storm patterns, and based on that, what cascading impact will be likely when the hurricane hits. Armed with this information, Kathy and other relevant stakeholders put together a strategy for managing response and recovery that matches the likely damage to be done considering the growing strength of the storm. The Ops Center team is able to quickly digest all of this information due to the EMC's generated reports, alerts, and visualizations. In this case, visualizations are key as they enhance comprehension, enable vast quantities of data to be reviewed quickly, and help create a shared view of a situation while aligning the Ops Center stakeholders on needed actions. The EMC relays this vital information via 3D maps of the city that are interactive, so Kathy and her ops team can dive into specific areas for more details. As these visualizations and reports are...
So this was a small example to show the kinds of capabilities that are made possible by these new technologies, and you could see clearly that one of the keys in making this happen was big data. And that's the reason, one of the reasons why we have at Chalmers created a new initiative called Big Data at Chalmers, which is jointly coordinated by me and Per Strand, who is the director of our eScience Center. And the idea is to bring together a consolidated resource that can help people in many different areas in which data is a key component, such as planning for smart cities and urban futures. Another thing that we mentioned in the discussion just before is other applications like green growth, health habits. And in this connection, I can just advertise that we have just been funded under the Horizon 2020 project for a center of excellence in high-performance computing that tries to bring the power of computing and data to address these problems. So this is exactly an example of the short film mock-up that we just saw before. One of our special strengths in this is the use of what are called synthetic information systems. So these are statistically accurate representations of real populations that you can use to make meso and microscale simulations with agent-based systems. And what you can use them is to create scenarios that you might want to experiment with. So if you had a particular type of, in that example, response to disaster, if you had a certain type of disaster coming up, what would be the best policy response? So you can explore those ideas using these synthetic information systems. So this is one of the special technologies that we at Chalmers will be developing in connection with this EU Center of Excellence. And one of the key application areas is smart cities, urban growth, and so on. So we mentioned cognitive computing and big data, and so the third thing in the title was deep learning. We already heard about it from Tapani when he talked about how it is being used in vision. And for me, I can add to that is that this will be a key component in these cognitive computing systems. Also, as Patrick mentioned, and as Kala mentioned earlier in the morning, a key ingredient that you need in these systems, like in cognitive computing systems applied to these kinds of problems, is the ability to understand and reason at a deep level. And deep learning is going to be a key technology in order to make that possible. So in Tapani's talk, he talked mainly about the use of deep learning in understanding images. And maybe in Kala's talk, also the focus was more on understanding images using these technologies. At Chalmers, our group and our collaborators here, we have been using deep learning in order to understand natural language. So our use of deep learning has been in the natural language domain. And this is, of course, going to be very key when you have human-computer interactions. You want humans to be able to interact with these cognitive agents. There must be a way to do the communication so that there is an understanding of natural language that conveys what each person or each party is trying to communicate to the other. And one of the interesting things that has emerged in recent years, in Sweden there's the word dunderhonung, the magic potion that makes things happen. And the magic that lies behind the development of natural language technology in recent years has been the use of deep learning to represent natural language components using representations that come out of deep learning, such as the ones we saw in the context of vision. But similar representations are also the key to understanding natural language as well. And we have just started work in this area. We have now already published a number of papers that show the use of these higher level representations in understanding natural language better. So to end, I'd like to end by showing you another short film. And this is just going to say that, well, there is, in this particular domain, for example, in order to facilitate understanding and communication between humans and computers, there's a lot of excitement. But this last film should be a somewhat sobering message to leave, that there are massive challenges ahead. We have just started at the tip of the iceberg. There is a massive challenge that still needs to be addressed. It's a very difficult problem. It's exciting, but we should keep in mind that it's a very difficult problem. And this little film will be the star in this film is, there are two people in this film. It's Bob Dylan, and he's talking to the IBM Watson system.
Bob Dylan, to improve my language skills, I've read all your lyrics.
You've read all of my lyrics.
I can read 800 million pages per second.
That's fast.
My analysis shows your major themes are that time passes, and love, fades.
Well, that sounds about right.
I have never known love.
Maybe we should write a song together.
I can sing.
You can sing.
Do-be-bop, be-bop-a-doo. Do-be-doo-be-doo. Do-do. Do-be-doo.
Thanks a lot.